Hey there guys, and welcome to this video on carboxylic acids. Right, so you need to know what carboxylic acids are. You need to know their functional group, which is the COOH group. You also need to be able to draw and name the first 4 carboxylic acids. Alright, you also need to know that they are, in fact, acids, as the name suggests, right? They're weak acids, but they do react like acids do, for example, reacting with carbonates. Finally, you need to know that carboxylic acids can react with alcohols in order to produce esters. And then you need to know a little bit about esters as well. So let's dive straight into that right now. Alrighty. Now, carboxylic acids have the COOH functional group. But what does that actually look like? Well, it looks like this. I'll just draw it bigger. It's carbon, which is doubly bound to an oxygen and then singly bound to an OH, right? And that OH, as you would have guessed, is just like an alcohol, OH, right? And so if we have a look here, we have our 4 first carboxylic acids, right? So the first one is meth, right? Because it's 1 carbon, right? And that's methanoic acid, right? The way that you name them is you say the prefix, so methan, ethan, etc., and then you put oic acid on the end. So this one here with 2 carbons is ethanoic acid, right? Ethanoic acid. You can obviously guess the next one's 3 carbons makes propanoic acid, and the 4th one is bute, so butanoic acid. All right, perfect. And that is the structure of them. Right now, notice that the carbon, which is bound to the OO and the OH, well, that takes up 3 bonds, so it's only able to bond to 1 more thing. So you don't have any hydrogens bound to that carbon aside from the one in methanoic acid. In the other ones, it's bound to 1 carbon, and that is it. Okay, so carboxylic acids, they are weak acids. So just like other weak acids, a carboxylic acid will react with a metal carbonate to produce salt, water, and carbon dioxide, right? It's a neutralization reaction, okay? A neutralization reaction, metal plus carbonate is a neutralization producing salt, water, and CO2, okay? You don't need to remember the balance equations for that, but you could, like if you saw it, you'd probably be able to recognize it. Okay, that's important. Carboxylic acids also react with alcohols to form esters. Now, this is really important. So, if I had a carboxylic acid, okay, which here is ethanoic acid, and here I'm adding to that methanol, because that is 1 carbon in an alcohol. All right, now what actually happens, well, I just jumped the gun there. What actually happens is your alcohol group and, well, basically both alcohol groups, but the alcohol group from the carboxylic acid, right? So the OH part of the carboxylic acid, of the COOH, yeah, and the hydrogen of the alcohol actually disappear. So what you really get is you get this carbon bonds with this oxygen, forming a chain. So it forms 1 molecule, right? And the OH and the H combine to form water, right? And so here you go. This is exactly what you get. OH and H makes the water down here, right? And notice that this carbon is now bound to this oxygen down here, and it forms 1 molecule, okay? It forms 1 single molecule. Now, the way that we name that is we name it using the alcohol first, and so the alcohol was methanol, and so we call this methyl, right? That's like the first little bit of the name, right? So methyl tells you which alcohol you used, and then this one was ethanoic acid, and so we call it ethanoate. Okay, so methyl ethanoate would be the resulting name of that ester, okay? So, you name it by using the alcohol and calling it "-yl", so it would be methyl, ethyl, propyl, and then the acid forms the rest of the name, so methanoate, ethanoate, propanoate, butanoate. Okay? Right, so that's basically how they are formed. You use an alcohol and a carboxylic acid. But what are esters and why do we care? Well, esters are found naturally, right, in fruits and other plants. The molecules, esters, actually are responsible for scents and they're responsible for taste, right? So they smell good, they taste good generally, and that's why we care about them. Okay, that we use them in order to try and replicate those flavors. So in synthetically flavored things, so for example, food flavorings or perfume to make it smell, in cosmetics, in body creams, etc., we use esters in order to give them that smell, or in foods to give them that smell and that taste, right? And so that is really important. And so those esters do occur naturally. We can produce esters to reproduce, if you like, the flavor of certain fruits. Some esters are only found in strawberries, some are only found in bananas, etc. And so if we reproduce those esters, you can reproduce the smell and or the taste of that fruit. And so that is one of the main reasons why we care so much about esters. Okay, so that was just very brief. I'm going to stop there. I hope that did make sense. But if you still have any questions, feel free to pop them in the box below or send me a direct email. As usual, please do like and subscribe because it really does help me out and I appreciate it. And of course, I look forward to seeing you in the next video.